You learn early on derivative of the sum of the derivatives. But that's included with the derivative of a difference, difference in the derivative, derivative of a product, derivative of a function. But that property, derivative of sum of the derivative, derivative of constant times function, is constant times the derivative, is a very important pair of properties. It identifies the term linear. Anything which has these two properties is linear. After we do section 2.2, everything for the rest of the course is linear. Chapter 5 is called linear algebra. And this idea is fundamental in chapter 5. Okay, so that's why this first order equation is called linear, because L is a linear operation. Yeah.
Can you just go back to page 14 really quick? Can you just go back to page 14 for like 4 more seconds?
Go back to which one?
Page 14.
Oh, page 14. Yes.
Thank
Okay.
you.
I'll do L of x squared. L of x squared is x squared prime plus 2 over x times x squared, which is 2x plus 2x, which is 4x. Oh, what does that mean? That means x squared is a solution of this differential equation. Right? L of x squared, that is to say, x squared prime 2 over x times x squared is 4x. 2x cubed plus x doesn't solve this differential equation. Either the 3x does not solve that, but x squared actually does. Okay. So, that's linear. All right? That's linear differential equation. Now we'll do separable. The idea for linear is not hard, right? Just multiply by even, put it in standard form, multiply by even the interval. Now, people have trouble because their integration skills are not up to par, let's say. Right? You have to worry about doing the integration. But I can say, hell, that's not my problem. You learned that in Calculus 1 and 2. This course assumes that you've mastered 1 and 2. So, my job is to just make sure that in general you get integrals which are doable. Right? For some of you, they won't be doable. But you practice it. Okay. Separable. This is the second kind. There's actually four kinds of equations you can solve. Linear, separable, which I'll do now. And then in section 2.3, there's what are called Bernoulli equations and homogeneous equations. We're going to omit that part because they're not as important as linear and separable. A second reason is you actually don't solve a Bernoulli equation, you transform it into linear and solve that. You don't really solve a homogeneous equation, you transform it into separable. So it's no big deal, okay, for our course under the circumstances to not worry about section 2.3. Because those equations are just transformed into linear or separable. Okay, so what's a separable equation? We start at the same point. We have y prime equals some function x and y. The equation is separable if this function here on the right, f, can be factored into a function of x times a function of y. Okay? So a separable equation looks like this. Y prime equals some function of x times some function of y. That's the standard form for a separable equation. Yes?
Is it still gonna be linear if y has a power like second or third, but it's only for the first power of y?
You mean,
If it's y squared or y cubed.
well, that's the idea. Well, I'll show you with examples. Sure, hell no. It can be any function of x times any function of y. Okay? Sure. Square roots, powers, logs, tangents, whatever, anything. All right. Find the general solution of y prime equal 2y. Remember, this was the first example I did for linear. Right? Example 1. I wrote this as y prime minus 2y equals 0. Linear. Right? And proceeded. Okay. Let's look at it this way. Let me write this as dy dx equals 2y. I can divide both sides by y and have 1 over y dy equals 2 dx. This is the basic idea of a separable equation. You've got an equation, and you can get all the y's on one side and all the x's on the other. That's why it's called separable, because you can separate the variables. Now we'll just integrate it. Okay? Integral 1 over y dy, integral 2 dx. This is ln y is 2x plus c. So here is the general solution. Now, can I whiz back to the example 1? Just look way back here. Very first thing I did. Here it is. We got y equals c e to the 2x, right? Right? And now we go back here, and I get log y equals 2x plus c. Exponential of both sides. E to the ln y is e to the 2x plus c, which is e to the 2x times e to the c, which is c e to the 2x. E to the c, c is arbitrary. E to the c is arbitrary. Call it c. And what is e to the log y? That's just y. So you see, this equation is linear, and you can solve it that way, or it's separable. Some equations are both. Most of our equations will not. Linear is pretty special, as is separable. Okay, another example. So I'm just showing you how to solve a separable equation, and you can now do, I guess, problem, I think it's 20 on quiz 1. Okay? So let's look at this. This is like something like problem 20, quiz 1. So this is x times y squared plus 1, right? So function of x, function of y. And when looking at separable equations, if you identify it as separable, you really want to write y prime as dy over dx. Leibniz notation. So this says 1 over y squared plus 1 dy is x dx. So identify the equation as separable. I separate the variables. And then I integrate it. Integral 1 over y squared plus 1 is what? Inverse tangent y. Integral x, 1/2 x squared plus c. Here is the general solution. There's another thing about a distinction between linear equations and separable equations. Linear equations, the general solution always winds up y equals some function of x. With separable equations, in general, your general solution will be an implicit function. This equation here defines y implicitly as a function of x. The goal is to solve this for y if you can. Sometimes you can, sometimes you can't. This time we can. Inverse tangent of y is this, which means the tangent of y, which means y, I'm taking the tangent of both sides, is the tangent of 1/2 x squared plus 6. So I can actually solve this implicit expression for y. Well, we'll see examples here in a minute where you can't solve for y, but you try. Questions? Right here? Here. This is the general solution. This is a better general solution. So separable equations, I have a few other things to tell you, but you get the basic idea of a separable equation. Separate the